This is a crash course on HCI and digital health, and this is aimed at people who are involved in research but who aren't researchers themselves. So you might be a participant of a research study, or you might just be in conversations about your experience within the context of the research. Um, so this is going to be focused on unpacking what does the research process look like, and why do researchers involve users in their studies. And this is going to be focused on HCI, which stands for Human Computer Interaction, and which is all about putting people at the center of the design process. Um, so within HCI, we'll usually have different stages of user research. So the it's easy to think of user research as kind of like a final step, and at the end of projects, but actually HCI and co-design is all about putting people at the center of the design process from the very start of the design of technology. So the researcher will need to find out information on all of these different stages of design. Um, and Starting with this discovery phase. So looking at what are the context, needs, behaviors, and challenges that users, so like yourself, experience in their day-to-day lives, and that's to give a sort of like background and a context for which any kind of design is going to sit. Um, and while researchers will come with their own problem statements, they'll also want to understand what does the problem look like in your eyes, as people who have lived experience within the research context. Um, so, for example, the problem statement that a researcher might come with is rare diseases are hard to diagnose. Um, so they're looking for interventions that may help support that diagnostic process. But then they might, once they speak to rare disease patients, realize actually from their context, from their point of view, the challenges are they feel really isolated when they're seeking diagnosis because no one understands what they're going through. And even in their consultations, it can be difficult to feel heard. And so the sorts of interventions that a researcher might look into is then very different to the original problem statement, which is supporting diagnosis for rare diseases. Um, so once the researcher has a really good idea of this discovery phase, they'll start to move on to the exploration phase. Well, they'll start to consider what are the design possibilities, where are there opportunities for interventions. And this often uses co-design workshops. So you might be involved in the design of the technology itself. And the idea of the co-designing solutions is that users essentially become part of the research team, or part of the team of designing the solution. So you work together, bringing your expertise, having lived in these contexts, and the researchers bringing their expertise, having worked on design interventions and understanding how to unpack sort of design from your experiences. And then once you get an intervention or a number of potential interventions, the researcher will start to sort of prototype and refine based on testing how well it solves the problem it's aiming to solve, how usable it might be, and whether it meets needs that aren't met by existing solutions. And they'll also want to explore and listen to the wider sort of impact. So does it meet the user's needs? So does it meet your needs? how do users respond to it, and think about where does it fall short, where is there room for improvement or for future work. And this is very iterative, and so it's not one one linear process where you move through each of the phases and then you're done. Actually, researchers will often go back and forth to try and improve and refine technology further, so that it's more suited to your needs. And one thing that's really important for you to understand is that you are the experts on your own experience. So our job as researchers is to work with you to design the intervention together. So we'll, like I was saying earlier, we'll bring the design skills, but we want to interpret your sort of lived experience, and to understand the user requirements and preferences from your perspective. And without your input, our attempts will probably fail. And like this example might demonstrate why that might be. So imagine the scenario that you ask a designer to make you a teapot. Now the designer doesn't know what a teapot is. So you have to describe this teapot to the designer so that they can make you one. And so you might say, well, a teapot has a spout and a handle and a lid. And if you're really clever, you might say, oh, it needs a steam hole so that it doesn't, build up pressure inside. And if you're really thinking it through, you might say, oh, it needs a hollow body so it can hold tea. And you're probably thinking of something like this. And so you have this conversation with the designer, and it sounds like you're going to get an amazing teapot. And then they come back with this teapot, and you go, oh, that wasn't quite what I had in mind. It's called a teapot for anarchists. And this just emphasizes, this is used as an analogy to highlight that designers are not users. So those with design experience, even if they have lived experience themselves of the condition or of the whatever context the technology is working in, they're not users themselves. So they might design something that's actually completely different to what you had in mind. So it's really important to involve people, the users who are actually going to be using technology throughout the design process. And one way that's really, really useful to do this is to use low fidelity prototyping. So fully implementing prototypes is quite expensive and time consuming. So just having an initial sketch can be really good to see, is that what you had in mind? Is that, is that right? And to kind of sense check early on without spending all the time sort of developing something really like polished and finished. So it gives that early indication of suitability. So you can imagine if in that teapot scenario, if they'd have sketched out what that teapot would look like, you'd have easily been able to say, oh, no, the spout needs to be on the other side. And so it can be really, really useful. And when it comes to technology, this initial prototyping might just be really basic sort of paper-based prototypes or static prototypes. So they're you can't interact with them, but it's just a visual representation of what maybe one screen might look like, or maybe a couple of different screens might look like. But then as you get more and more refined, and there's sort of they've got a reasonable understanding of the technology you want, they might start to move on to front end prototypes. So this often uses technology such as Figma, which essentially works as a glorified PowerPoint. So it goes to the next sort of image essentially when you click on a certain place in the screen. So you get what feels like a working prototype. So you press on buttons and it'll take you to the next screen, but there's nothing actually going on in the back end. that can be really useful because you can get the experience of what would it be like to actually use the app and play around with the technology without them going to the cost and the time of actually fully implementing it. And so it can make it easier to make lots of changes throughout, without it taking a really, really long time. And essentially this process, it links to this double diamond you can see here. So similar to the 4 stages of user research that we talked about at the start, the double diamond is another representation of HCI research. So it starts with discovery, looking at what is the challenge, what are the where is there opportunities, what's the context, and then defining that sort of like that specific where the intervention might sit and what it aims to do. And then when it comes to prototyping, then there's going to be a number of different designs. So they'll start to think about, okay, what are the potential interventions? So they'll expand the number of possible solutions, and then they'll start to refine based on your feedback and refine it down to one cohesive design. But it's great to get feedback early on in the design process, but there are also some mistakes that are probably avoidable just off the bat, and design principles to know that hopefully researchers will avoid. But this can also give you a voice in terms of to understand why maybe technology isn't easy to use. So first of all, consistency is really important with technology. You don't want to have to relearn how to use an application or a website every time you come across a new website or a new application, or any other piece of technology. Actually, you don't really want to have to relearn all of those things. So things like being consistent with other applications can be really helpful. So you probably all know the symbols, the icons, copy, paste, search, menu, and save, because they're consistent throughout different interventions, different technologies. And so this is why consistency can be really powerful, because you don't have to relearn every time. But another really important principle is to have good feedback and clear visibility of system status. So you can see this example on Instagram. When you hover over home, it sort of like highlights it, and then when you click on it, it sort of grays out as if you've pressed the button. So it's very clear from that you get feedback that the button has been clicked, and even if the page doesn't immediately load, you know actually that's clicked, and you're not kind of unsure, oh, did that not click, did I not press hard enough on the mouse? It just gives you that sort of feedback and that better understanding of how the system works. And similarly, it's really important to have confirmation messages to provide closure. So when you are finishing an action, so for example, if you had a online shopping basket, you put all your credit card details in, you press checkout, and it takes you back to the home page. You'd be like, oh, did it go through? Is that working? But just by having a sort of success message saying, okay, that went through, your shopping was successful, then that would kind of provide that confirmation and provide that closure. So you wouldn't be having to check emails or your account to see where the card account, if it's come out of your balance. So that can be really, really important as well. And then there usually should be an awareness for allowing shortcuts for more advanced users. So for example, if you're going to be using the technology day in, day out, and you're using certain functions all the time. So, for example, people who are using a computer on a daily basis, who like might be copying pasting very regularly, and so they might use the keyboard shortcuts like Control C and Control V to copy and paste, and that's a way of kind of making it easier to go through those sort of like very frequent tasks just a little bit more quickly. Another thing to be for researchers to be aware of, and for you to know kind of why technology might not work, is affordances. So I'm sure many of you have come across a door with a pull handle, but actually it says push, or maybe it doesn't even say push, but actually it was a push door, and that's why the door isn't opening when you're pulling it. And that's really frustrating because you're actually it's quite an easy task, but it's just been made more difficult because that handle is signifying that you should be able to pull it. So just having a flat plate makes it so much easier that you can immediately see, you can push that door. And that's something that also we can have affordances in technology, and we can signify certain functionalities in the same way, and we'll go into a little bit more detail on that in a bit. But we also have mapping, so having a hub where the knobs to turn on each hub actually spatially corresponds to the hub it's turning on. That's so much easier to use than having a hub where all your controls are in a line and there's maybe a tiny little diagram that might be a bit faded and you might not be able to see, that actually says which hub it's turning on. And so actually you can see how mapping can be really powerful as well in making something easier to use. It's also technology should in most contexts have a more minimalist design. So less is often more, because we can only process so much information at once. And so if you look at the sort of screen on the left, you can see actually there's so much information. It's kind of a bit overwhelming, and it's harder to pick out the key pieces of information from that. And then the phone screen on the right, actually you can see the balance on the accounts actually much more clearer, and then the statistics is made smaller, and you still actually get 90% of the information, but it's so much more readable, and the information actually you are commonly looking for is just very clear and upfront, but then if you did want additional information like the address of the transaction history, you could always click in and see that information, but you don't actually need it on the home page. And one thing that's quite amazing, I think, about people is when we understand how an object or how technology works, we essentially become free with it, and we'll play around with it. So a user freedom can be something that's like really powerful with technology, and so you might get something like called design appropriation. So you might actually see uses of technology that are outside of the original design that the designers intended. So you've probably seen many of these sort of like 5-minute hacks to do this thing, or like 5-minute kitchen hacks to lots of different sort of videos that will often talk about design appropriation. They won't say that's what it is, but that is essentially what it is. So in this example, you've got a cupcake case to catch the drips from your ice lolly. So a cupcake case is never designed for that, but actually it's a really good use of that, and it makes a lot of sense. And so you can have that with technology as well. So for example, you might use Google as a spell checker, not even searching the word you're trying to spell check, but using the autofill, the autocomplete function to check, oh, was that spelled correct? And that could be so that's one example of how you might use technology outside of its original design purpose, but how that actually can be really, really powerful. And when all else fails, so as much as we'll always try and design technology that's as usable, as easy to use as possible, there are going to be times when users do something unexpected, or the system does something unexpected. And so it's really important that you're not then completely stuck and shut out of the system, but actually you can recognize and recover from what the error is. So you can see this screenshot on from Outlook where it says something went wrong. Please try the recommended action below. Refresh the application. And if you click on more details, it says things like the UTC date, the client ID, and most users aren't going to be able to work out, okay, what is the problem here? If you refresh the application and it still didn't work, that's going to be really confusing, and you're going to be like, well, what do I do? What do I do? So having specific error messages can be really, really important for this. So for example, in forms, there's often much better error messages where it will say name field is required, or you need an additional character, or you're using an invalid character, or something like that. It'll give you explicit details of why it's not submitting, and that can be much more helpful. And just being able to undo is so important. It could be really frustrating if you accidentally press a button and it like clears all your information, or the page times out, and or all of the information you've been writing in it clears, and there's no way to get back to that point. Whereas if you have the ability to kind of like undo or like redo and kind of move back and forth throughout the website or app or whatever intervention you're using, then actually it takes the stress out of it and you can just use it more freely. So that's something to be aware of, and that's one of the reasons technology might not work as well as you need it. And when you do have technology that works well, you essentially will probably start to build a mental model of the system. So the designer will have their own mental model, and then they'll make a system based off their mental model. And then you'll use the system, and looking at the image of the system, so not the system itself, you probably won't be looking at the code and the sort of like inner workings of the system, but you'll look at the image, and you'll start to develop a mental model. And so the best technology will enable you to develop a mental model that's actually accurate of what's going on underneath. And so by allowing users to kind of undo and go back and play around with the system freely without the stress of what if I do this wrong and I lose all this information, or without all of those stresses, actually it allows the user to start to learn and to develop a mental model of how the system works. And so a little bit more detail on the mappings we looked at. So the example with the hubs, we talked about spatial mappings. So we can often relate spatial mappings to hardware. So we can kind of recreate that sort of like hardware spatial mapping of the two monitors you can see. into the window of the settings so that you can see actually screen 1 corresponds to the screen on the right, and screen 2 corresponds to the screen on the left. And you can see that there is a spatial mapping. And if you had a screen that was above or below, then you could drag those boxes and move it so that it represents the layout of your screen. So that's one example of spatial mappings. But beyond spatial mappings, we actually have other types of mapping. So something called behavioral mappings. Essentially, the idea that sort of like unpitching is you're stretching the image. So that's sort of mapping the behavior of stretching the image to the user input. And again, like pinching would then be kind of like unzooming and unstretching that image. And then we also have conceptual or metaphorical mappings, which essentially up conceptually is more and down conceptually is less. So up would be brighter and louder, and down would be darker and quieter. So that sort of makes sense because it's that parallel to the concept that up is more and down is less. We talked about affordances and this false affordance of trying to pull a push door, and so there's lots of different types this can look like in technology, and one thing you probably see a lot is actually negative affordances, which means when you cannot do something, it will sort of like highlight that that's not possible. So you might see a save button is grayed out. That signifies to you that you can't press save yet, and some things you maybe need to do another action before you can submit save. And ideally, if you click on that, you also get that error message of why can't you do that action yet. But that could be really powerful in that that's not an option, so you're not going to click on it and be like, why isn't it saving? Did it save? Did it not save? And it just signifies you can't do that yet. We also talked about consistency already, and so these can be also called pattern affordances. So essentially consistency among technology, but they can also be considered as metaphorical affordances. So they actually are related to the real world for some of these. So for example, having a clipboard for pasting information, so you can imagine you're adding information onto your clipboard. Having the search icon be a magnifying glass, so you're looking into something in front of you, you might have a magnifying glass, and a floppy disk to save anything. So now it's probably more common to think of it as a save icon, but actually back in the day you would be saving your data on floppy disks, which look like this. So these are all metaphors for the real world to make it a little bit more obvious as to why or as to what the function of the icon is. You probably have seen animated affordances. So this sort of like loading wheel, it just tells you that yes, it's processing, something's going on. And something that's actually really powerful, especially when we think about sort of more expert users, is hidden affordances. So being able to maybe right click on a computer, or maybe like press and hold on a phone, you might be able to see additional menus that aren't necessarily obvious that you can do, but as you do that, you might see, oh, there are additional options here. So that can be particularly useful for expert users who maybe want to use functionalities that most users don't want to look at. And you can also have explicit affordances. So this is where it tells you click to play the video, and that just explicitly tells you what to do in that context. And then more specifically within health, researchers should really consider the capacity and the context on patients or clinicians or whoever else might be involved in the technology. And cognitive load and time limitations might be particularly relevant for clinicians if they're really, really busy, or you know, if they're really kind of overworked, then actually adding to their cognitive load and you know, adding something that's going to take a lot of time is probably not realistic in that context. But with patients, they might have actually a bit more time, but they might actually have more fatigue, or they might not be interested in engaging with technology long term. So that's something else for researchers to consider, and that's something you can reflect on: is this engaging for me? Do I see myself continuing to use this app or this whatever intervention it is long term, or is it something that I might use for a week and then stop using? And you can think about why that might be and what might actually encourage you to continue using it. And another thing you might be aware of is, you know, if you are a patient, you might not have, you know, the health literacy to interpret all of the information you're given, or that you might be unsure about certain things. So that's another thing to kind of flag up that might be an issue. And when it comes to health, a poor user interface can create risk, particularly with clinician facing and more sort of like medical devices rather than sort of self-care. And particularly sort of numbers are really important, that there are sort of clear units and a decimal point. So you can see this 2.4 on this screen of reading this blood. That you might actually miss that decimal point, because actually it's very close to the 2, and it would be very easy to see that as 24, and then you might be unsure what units you're working with. You might not really understand what that means, and so just having a very clear decimal point and unit would actually make sure there's no sort of ambiguity on what that means. And similarly, with handwriting fonts that sometimes some systems will use, micrograms is 1,000. So 1,000 micrograms is equal to a milligram. And so this μg that you can see handwritten at the bottom of the screen, that is 1,000 is 1,000th of the mg that you can see on the right hand side. But then in this middle area, actually it could be ambiguous on which one it is, and that's obviously quite significant. If you have these different units, that would be a very significant difference in medication. And so that's why it's better practice to use mcg instead of μg, and to make sure that's really clear. So that's another thing that you might feed back on, is to make sure the units are really clear in that respect. But it's very easy with technology to put in error checks and safety measures. So if someone did put in a dosage that's into a system that's way out of proportion, you could error check that and say, are you sure this is what you mean? Because this isn't within an expected range. And so that can be another check to kind of check the units and make sure there's no, like, to reduce the risk of an error in that respect. But another thing is accessibility and health equity. So if you have cognitive and learning disabilities, or visual impairments, speech impairments, hearing impairments, or motor and dexterity issues, then you might find it difficult to use technology if it's not designed to accommodate your needs. So just being aware of where those needs are, and really voicing where there might be barriers to using that technology. And it might not even kind of stop you from using the technology completely, but it might make it harder to use. So for example, if you were visually impaired but you were still able to see, you weren't completely blind, so you needed a high sort of like color contrast, you might still be able to use it but struggle, and it might take you longer. Or if you were dyslexic and there was lots of really, really text heavy kind of information, you might be able to get through that information eventually, but again, it's not designed around your needs. And so this can be really useful to voice, especially in early stages, so that the researchers are aware and the designers are aware to take those needs into account. And I also touched on this earlier. Another thing to be aware of is your like health literacy and tech literacy. Is this something that actually you would need a little bit more explanation on the sort of like health information, or anything that requires you to have a certain knowledge? Actually, maybe you need that requirement to be lower, and that's something that's really important to voice, because it could be easy for researchers to not realize when they've assumed information. And then tech literacy. So you might find actually you need a really simple intervention, something that's really easy to use, and that's something that's also really important to voice. You might, if you're an older adult, you might have you might be less comfortable with using technology, and you might be less likely to have a smartphone, and so availability of devices is also something to voice. If you don't have the device, or people who don't have the device that an intervention is being made for, to ask those questions. What if I didn't have my device? What would I still be able to access support for this? So the main takeaways, think about the mental model. Is the technology being designed around your mental model? Is it able to facilitate your understanding of how the technology works? Are researchers involving you at each of these design stages? And you can think about, what design stage are you in? What is the researcher trying to get from you at this stage? And that could be really helpful, so that actually, I could give this information, and it can kind of situate your discussions and your studies. But the biggest thing is, you are the expert in this, so you are the one that's going to be bringing all of that richness of your life experiences, really, and that's so valuable. It's gold dust for researchers. So just an encouragement: do share that. We want to know, as researchers, we want to know your experiences, and that's the whole point of user research. So thank you for listening.